All right, let's continue. All right, so for step 4, we say for the step 3, we just got the p-value. Right, so it doesn't matter it's from the z-test statistics or t-test statistics, we got a p-value, right? And then we want to use the p-value to make our conclusion. All right, okay, so then actually, let's review a little bit. All right, so when we talk about the idea of the hypothesis testing, we say for this part, right, so when we talk about this probability that the null hypothesis is true, actually we are talking about the p-value, right? So that means this is our step 3. And then from step 3, we got a p-value, and then next, we want to make our conclusion. Based on what? Based on the p-value is small or big, right? So then in this case, how big is big? How small is small, right? So we do need a standard. All right, so then actually we want to set up a standard, kind of standard, right? So we want to compare the p-value with the alpha. All right, so then it's time for us to talk about the real definition for alpha. So when we talk about the confidence interval, we say if we are 90% confident about our results, that means the alpha will be 10% or 0.1, right? So then we call the alpha is kind of the error rate that we can allow, right? So kind of the same idea here. We say alpha is our standard or the maximum error that we can allow in this hypothesis testing process. In more details, alpha is the probability that we make the type 1 error. All right, okay, so then let's think about what is type 1 error. And actually, we have 2 types of errors in this process. Type 1 error and type 2 error. All right, so what is type 1 error? We say we defined the type 1 error as when the null hypothesis is true, but at the end we reject it. So this type of error, we call it is the type 1 error. And type 2 error will be the opposite, right? Totally opposite. We say when the null hypothesis is false, but we fail to reject it. All right, so then it's time for us to think about which kind of error is a bigger problem for us. It's like, okay, an innocent person, but we said he is guilty and sent him to death, something like that. All right. The other way, type 2 error is this person is actually guilty, but we fail to say he is guilty. So which kind of error is more serious or produce more bigger problem? We can think that most of the time will be type 1 error, because if the person is already dead, then you cannot just make him alive again, right? So then the other one, type 2 error, is even though now I said he is not guilty, but in the future when we have more evidence, we can continue to say, okay, this person is guilty. It just for now we fail to say it is he is guilty, or something like that. All right, so then we say type 1 error is more important, or the thing we care more in our hypothesis testing. And we define the probability of type 1 error is the alpha, which is the highest error that we can allow in this hypothesis test. Right, so let's say it is the maximum error. Sorry. Allowed in this hypothesis test. So then in this case, we kind of have a standard, right? So we say if this p-value is less than this kind of error rate, then what? Then we say this p-value is small enough. That means we want to reject the null hypothesis. All right, okay, the other way, let's just make a block to separate with other stories. All right, the other way, if your p-value is larger than the maximum error rate, that means this p-value is large, right? So then based on the idea of the hypothesis testing, we say we fail to reject the null hypothesis. All right, the problem is this enough for us to make the conclusion? To reject the null hypothesis or fail to reject the null hypothesis? Let's come back to our step 1, right? So when we state the hypothesis, what do we want to test? We say the alternative hypothesis is our claim, right? Is our claim, and is this thing we want to test about whether this claim is correct or not correct. And then we say the null hypothesis is kind of a statement corresponding to the claim, right? So actually we say the null hypothesis is always mu equals to mu 0, and claim alternative hypothesis depend on what do we want to test. So then actually we want to know what? In the conclusion, we want to know whether the alternative hypothesis is correct or not. It is supported or not. We actually don't really care about the null hypothesis, right? So then in the conclusion, in our conclusion, we say this is still our idea of the hypothesis test. We say if the p-value, this probability is small, then that means the null hypothesis is unlikely to be true. That's why we want to reject the null hypothesis. But to be responsible to our customers, we don't care about the null hypothesis. The customers want to know whether their claim is correct or not correct. So here in this course, right, so it doesn't matter what you learned before, right? In this course, I need you to have the second step, the further step, to tell your customers, right, whether their claim is supported or not supported. So that means if you reject a null hypothesis, remember we always have a pair of hypotheses, right? So if we reject the null hypothesis, that means our alternative hypothesis is supported. That is why we have one more line for our true conclusion. We say we have enough or sufficient evidence to support our alternative hypothesis, right? This is our true conclusion. In your essay assignment or in the exam, if you just stop here, it is not a conclusion. You get no credit on it. All right, just to be careful about this. All right, correspondingly, the other way, right? If we fail to reject a null hypothesis, if you fail to reject a null hypothesis, that means there is not enough evidence to say the null hypothesis is not true, right? So the other way, we say we don't have enough evidence to support our alternative hypothesis. All right, so again, in this case, right, we say if we reject the null hypothesis, that means we have enough evidence to support the alternative hypothesis. You can also say the alternative hypothesis kind of be supported or accepted, right? It doesn't matter. But for the other one, right, we don't have enough evidence to support the alternative hypothesis. It doesn't mean the null hypothesis is true. It also doesn't mean the null hypothesis is accepted. It doesn't mean the alternative hypothesis is not true. Right? So similar idea to the innocent and guilty example. We just, right now, we just don't have enough evidence to support your claim. It doesn't mean that your claim is totally wrong or not true. We just don't have enough evidence to support it. In the future, right, if you have enough evidence, we can still support your claim, right? So this is kind of a logic here, right? Just to be careful about it, right? We just say don't have enough evidence to support your claim. All right, and of course, when we have a detailed question or problem, we do want to replace the detailed HA in your conclusion, because your customers will never understand what does HA mean if he or she is not a statistical person, right? So we do need to replace this HA with the detailed statement. All right. Okay, so then I think that will be all for the hypothesis testing. And now let's go through the example. All right, so of course we do need to remember, or you do need to remember this rejection rule by yourselves, right? We will need to use this many times, right? And this will not be on your formula sheet, right? So you do need to remember it. All right, so then let's go through this example in more details. So we say in the United States, the average car is driven about 12,000 miles each year. The owner of a large rental company suspects that for his fleet, the mean distance is greater than 12,000 miles each year. He selected a random sample of n equals to 85 cars from his fleet and find that the mean annual mileage for this sample is 12,375 miles, and the sample standard deviation to be S equals to 2,015 miles. All right, so I make this question easier because I just label them, right? So I just kind of gave the notation for almost all the numbers or values, right? So then when you try to read the question, of course, the first thing we want to find out the useful information. to start our hypothesis, right? So then we say step 1, state the hypothesis, right? And then we say the hypothesis should be in a pair of null hypothesis and alternative hypothesis. And what do we need to test here? We want to test about the mean distance, right? And then what is our claim? We say the owner of a large rental company suspect that for his fleet, the mean distance is greater than 12,000 miles each year. This is his claim, and we want to test for his claim, right? So that is why alternative hypothesis should be this one, and correspondingly, before he has his idea, in the United States, the average car is driven about 12,000 miles each year, right? So that will be the original status. All right, and then from this step, we kind of know that this is a right tail hypothesis, right? Okay, and then step 2, we do need to calculate the test statistics. And before we can calculate based on the formula, we do need to check these 2 assumptions, right? You also need to show me kind of similar information in your essay assignment or in the exams. All right, so we do need to check the independence and normality. For independence, we need to check whether the sample is randomly selected. So it says he selected a random sample. That means the sample is truly randomly selected, right? So this is good. And then next one, we do need to check n should be less equals to 10% of the population size, right? So then here, the sample size n equals to 85, right? So then we also need to know the population size, but in this case, we don't know the population size. I don't know how large is the population, but can you kind of imagine? Yes, right? So actually, what is the population here? The population is all the cars in the United States, right? So that will be a lot. I don't know the detailed value, but I know the population size n is quite a big number. So then, of course, 85 should be less than 10% of all the cars in the United States, right? So then normality, n is 85. Of course, it is larger than 30, central limit theorem, and checked. All right, so only when these 2 assumptions are checked, we can continue to calculate our test statistics. But remember, in our step 2, we need to decide we have the z-test statistics or we have the t-test statistics, depending on whether the population standard deviation is given or not given, right? So then let's come back. Let's read the question, right? So in the United States, the average car is driven about 12,000 miles. So then what is the notation for this 12,000 miles? If you want to label them, label it. What is this 12,000 miles? What is the notation for it? Actually, in your step 1, we know we want to test about this 12,000 miles, which is our claim value, right? So this 12,000 miles is our mu0. All right, and then the owner of a large rental company suspects that for his fleet, the mean distance is greater than 12,000 miles each year. So this is still our mu0. Now he selects a random sample of n equals to 85. So now I know the n is 85 from his fleet. And find that the mean annual mileage for this sample is 12,375. So what is this number? What is the notation for that? This is the mean for the sample. So then that will be our x bar, right? And the sample standard deviation is S, which is 2015 miles. All right, now we have kind of all the things in this question except the population standard deviation, right? So we cannot find the population standard deviation sigma. That means we need to have the t-test statistics, right? Okay, so then we have the formula t-test statistics equals to x bar minus mu 0 divided by, so here some of you got confused. We have the t-test statistics x bar minus mu 0 s over square root of n. All right, so x bar is sample mean, which is 12,375. Mu 0 is our claimed value, which is 12,000. All right, and then S is our 2015 and N is 85. All right, and then in my solution here, I actually got a extra step. I calculate the bottom first, S over square root of N. We call this part is the standard error, right? Remember, the sigma over square root of N is called the standard deviation of the sampling distribution. But now, since the population standard deviation sigma is not given, then the sigma is replaced by the sample standard deviation. So then S over square root of N is not called the standard deviation anymore. It is called standard error. All right, so that is why I label it as the standard error of sample means, which is S over square root of N. And I calculate the bottom and then just replace the bottom with this value and calculate the t, which is 1.76. Okay, so now we have the t-test statistics, which is 1.76, and then what? Then, of course, we go to the next step. We want to use this to find the p-value, right? Okay, so then to find the p-value, we say now we have the t. What is the procedure? This is the procedure, right? So we have one-tailed or two-tailed. I think we have one-tailed, which is the right-tailed, right? Okay, so then we want to follow this procedure, right? We want to focus on the degree of freedom line, and within this line, we find where is my t-test statistics. It should be between two values, go up to find the corresponding p-value. All right, okay, so then let's try it, right? So let's think about the detailed case in the t-table. We want to find the degree of freedom, so which is n minus 1, 85 minus 1, which is 84. So then focus on this row. I want to find my t-test statistics, which is 1.76, should be between two values, so that I can go to the top to find the range of the p-value, right? Okay, so then let's go to the t-table. Degree of freedom is 84. So that will be this row, right? And then 1.76 is between these two, right? 1.76 should be larger than 1.66 and less than 1.98. That means we want to go directly to the top. That means your p-value will be between 0.05 and 0.025. Okay. So that means your p-value is between these two. How to write it out? We say your p-value should be larger than the smaller one, which is 0.025, less than 0.05. All right. So even though we have a range of p-value, it is enough for us to make the conclusion. Now here is the example, right? I made two kinds of significance level, or alpha, right? So alpha here is called the significance level. All right, so then I just made two cases, right? So if I said the significance level alpha is 0.05, all right, then what is your conclusion? Think about it. We say your p-value is larger than 0.025, less than 0.05, and now your alpha is 0.05. So that means here is my alpha. Of course, what is the relationship? That means your p-value is less than alpha, right? So if your p-value is less than alpha, then what is the conclusion? Let's look at our rejection rule, right? So we say p-value, we say if p-value is less than alpha, then we reject the null hypothesis so that we have enough evidence to support our alternative hypothesis, right? So then in this case, we say we reject the null hypothesis, but remember, this is not our conclusion. We need to continue. We say what? We say we have enough evidence to support our alternative hypothesis. Okay, now can you leave this alternative hypothesis, this HA, in your conclusion? For the same reason, right? The customers will never understand what does the HA mean. So then we need to come back to our step one. So what is your alternative hypothesis? That means mu larger than 12,000 miles, right? Again, non-statistical person will never understand what is a mu, right? So then what is mu here? The mu is the population mean distance, right? Okay, so then combine them together. What is our conclusion? That means our mean annual mileage for the rental car fleet is truly greater than the national average of 12,000 miles. All right. We start with our statistical language because it is easy for us to go through the procedure. But at the end, we need to come back to our goal. We need to answer the customer's question in our human language. All right. The other way, if my alpha, the significance level, is not 0.05, or I can only allow 1% of error rate. That is why I set alpha equals to 0.01. So now if alpha is 0.01, but remember our p-value will not be changed because of alpha. Our p-value is still 0.025 and less than 0.05. But now our alpha is 0.01. So then what is your conclusion? What is the relationship between p-value and alpha? We say from this side, we know the p-value is larger than 0.02. Of course, it is also larger than 0.01, right? So then in this case, we have the conclusion that the p-value is larger than alpha. Okay, now if you have the p-value larger than alpha, of course, we say we fail to reject the null hypothesis. Again, this is not a conclusion. We need to continue. We say we don't have enough evidence to support the alternative hypothesis. All right, so again, we do need to replace this HA with our human language, right? So then we say we don't have enough evidence to support that the mean annual mileage for the rental car fleet is greater than the national average of 12,000 miles. All right, so that will be the whole example, and it is your time to go through this practice. All right, okay, and then here, to get everything easy, I even just gave you 4 partial questions with these 4 steps, right? Fill in the blanks, right? Try to understand what are they. All right, okay, and if you're done with this practice, you can go to the Canvas and you can find the solution there, right, and compare the solution with yours. All right, and then actually we have one more topic to go in this hypothesis testing chapter. We have already talked about the confidence interval and the hypothesis testing, and we can see that there are several common things between these two, and sometimes you got confused and sometimes you got them connected. So what is their real relationship between these two things? All right, so we say, let's go through this example first, right? So for example, we want to test the following hypothesis, which is we want to test the population mean is 78 or different from 78. All right, and normally we want to go through this 4-step hypothesis testing process, right? So we want to, this is our step 1. We want to calculate the confidence, we want to calculate the test statistics, and we want to use the test statistics to find the p-value, and then we want to compare the p-value with alpha so that we can get our conclusion. But in this case, I give you a actual information. I say, I also have the 95% confidence interval for the population mean mu, which is 70 to 80. Now, what is the conclusion based on this information? Without knowing X bar, without knowing the S or sigma, without knowing the sample size, I have a actual information about about the population means confidence interval. So what does that mean, or what is our conclusion? We say now we have this confidence interval, and it is from 70 to 80. So what does that mean? We do know how to interpret, right? So we say we are 95% confident that the population mean mu is between 70 and 80, right? Okay, now think about this hypothesis. What do we want to test? I just want to test whether the population mean is 78 or not 78. It can be 78 or it cannot be 78. Now, based on this confidence interval, can it be 78? Can the mu be 78 or not? In this case, we say we are quite confident that the population mean is between 70 and 80. So of course, right, so this is the idea of the confidence interval, 70, 80. I don't know where is the population mean, but since 78 is within this range, of course, the population mean can be 78, right? So then in this case, that means what? That means the null hypothesis is likely to be true. That means we fail to reject the null hypothesis. That means we don't have enough evidence fail to reject the null hypothesis. That means we don't have enough evidence to support the alternative hypothesis. Because the population mean can be 78, right? Okay, the other way, if the 95% confidence interval is not 70 to 80, instead it is 70 to 75, that means now I got a confidence interval from 70 to 75, sorry. Then I want to know the population mean can be 78 or cannot be 78. Where is 78? Out of this confidence interval, right? So it's kind of this last question in your essay assignment 1, right? So then we say we are quite confident that the mean, population mean, falls in this range. That means the population mean cannot be 78 because it falls outside of the confidence interval, right? So that means the mean cannot be 78. That means what? That means we reject the null hypothesis. That means we have enough evidence to support our alternative hypothesis. All right, but the other way we say, when we talked about this example, right, whether you reject the null hypothesis or you do not reject the null hypothesis depend on what? Depend on your alpha, right? So if you have different significance level, then your conclusion may be different. Because when you set your standard differently, then your conclusion will be different, right? So then in this case, we say when we have a conclusion for a hypothesis test, we do need to specify what is my alpha. Otherwise, my conclusion is not complete, right? I don't know what is my standard, right? So then in this case, what is my alpha in this example? What is my alpha? We say, when we talk about alpha, alpha is kind of the error rate, right? So then in this case, if this confidence interval is 95% confidence interval, that means your alpha will be 0.05. We set the standard as alpha equals to 0.05. All right, so that is why here I gave you a summary. We say if the hypothesized value falls outside of the 10%, outside of your confidence interval, then we reject the null hypothesis at the alpha level, which is 1 minus or 100% minus your confidence level. Right, the other way, if your hypothesized value falls inside of your confidence interval, then we do not reject the null hypothesis. All right, I don't want you to remember or memorize this U, right? So this, you have already memorized a lot of U's. I don't want to give you 2 more, but I want you to understand the whole idea here and think about it by yourselves. All right, okay, so then your question may be, okay, what if in this example we have 2-tailed hypothesis, but what if we have 1-tailed hypothesis, left tail or right tail? Would us just to have the same conclusion? The answer is no. All right, so remember the relationship between the hypothesis test and confidence interval only exists when this hypothesis test is a 2-tailed hypothesis. if this hypothesis test is one-tailed hypothesis, then there's no relationship between the hypothesis test and confidence interval. Not at all. Why is that? Think about the confidence interval. You start with the sample mean. We allow the margin of error to the left and to the right so that we have a confidence interval. So then actually you can consider a confidence interval as two-sided thing or two-tailed thing, right? But if you want to compare the confidence interval with a one-tailed test, it's just like you compare a two-sided thing with one-sided thing. It will be unfair, right? So we never get connected between a one-tailed hypothesis test with a confidence interval. They have no relationship. This relationship only exists between a two-tailed hypothesis test and the confidence interval. All right, that will be all for this chapter. And here is something you want to learn more about how to do it in JUMP. In this course, this is not required, right? But I just want you to kind of try, because it will be similar idea if you have a graph calculator, right? You just follow these steps and then enter these values in this kind of a calculator, and then you will have the corresponding p-value available. But this is not required. You can just try it by yourselves or use this example to check your results in your essay assignment, right? Why not? Okay, all right, so I think that will be all, and I feel lucky that I didn't cough a lot in this video. All right, so see you on Monday.